Hey guys, we are graphing some exponential equations today. So you see I have an x in my exponent, okay? So if you've been graphing things like parabolas, absolute values, square root graphs, you've probably been used to having a parent graph, and then depending on what your equation looked like, just changing that parent graph around to get your graph, right? We're going to be doing that same thing. It's just a little bit different, and let me show you why, okay? This is kind of what I go off of to know what my new graph is going to look like, right? And because of this b, right? In this equation, b is 4, but it's not necessarily always going to be 4, right? So depending on what that number is will change what your parent graph looks like, okay? So in math, there's usually more than one way to do things, right? But what we're going to do is we are first going to figure out what the parent graph looks like, and it could be different for each equation you do, right? And then we are going to do these changes, okay? You're probably used to this if you've been doing those other graphs we were talking about. In this one, we don't have an A out front. Well, it's technically a 1, so we don't really have to worry about it, right? I will link a video in the corner where this does apply, right? It can change what my graph looks like, and it can also reflect it, okay? But that doesn't apply here. What we are going to do is figure out what my graph is going to do after I figure out the parent graph, right? So this number here, this -2, tells me how far my graph shifts to the right or left, and we go opposite of the sign, right? So -2 usually makes me think to the left too, but we're gonna do opposite, so we are going to go to the right 2, okay? After we figure out that parent graph. Okay, now this -5 on the back tells me how far my graph is going to shift up or down. We stick with the sign, so that means we are going to go down 5. Okay, now what is this parent graph I have been telling you about? Okay, we are going to have our parent graph be y equals a times b to the power of x. Okay, what does that mean? Like I said, we don't really have an a here. Oh, guys, I dropped my marker. Here it is. Sorry, I dropped it on the last video. I found it. Okay. So my parent graph is going to be, for this one, y equals 4 to the power of x. Okay. Do you see how that's this equation just without these guys? So we're going to figure out what that is and then apply these guys. Okay. So let's figure out what it is. We're going to use a table. I know you love tables, right? You've probably, if you haven't done one for a while, you've been missing them, okay? So here they are. All right, we are going to graph -1, 0, 1, 2, and 3. This will give me a pretty good idea of what this graph looks like, okay? So I'm going to plug these in pretty quickly as exponents. If you're like, oh man, I need an exponent refresher, I'll link a video in the corner for you, okay? So when I plug in -1, I get y equals 4 to the power of -1, which will end up giving me y equals 1/4. Okay, if you're like, what the heck did she just do there? I'll link a video talking about negative exponents, okay? So when I plugged in -1, I got 1/4, okay? When I plug in 0, anything to the power of 0 is 1, right? So when I plug in 0, I get 1. Again, sorry, I feel like a broken record, but if you want to know why anything to the power of 0 is 1, I'll link a video in the corner, okay? All right, 4 to the power of 1 is going to be 4, right? 4 to the power of 2 is going to be 4 times 4, which is 16. And 4 to the third power is going to be 4 times 4 times 4, which gives me 64. These graphs get steep really fast, right? So I'm not even going to be able to graph this whole thing, right? But I've got -1 and 1/4, 0, 1, 1, 4, oh man, and 2, I'm already off my graph, right? It's going to be like here-ish. Oh wait, no, probably a little further down. I don't know. We'll pretend right there, okay? So it doesn't have to be perfect. We just know it gets steep pretty fast, right? Also, my graph is going to get closer and closer and closer to 0, but never actually touch it and pretend like I can draw this very well. And then we just know it gets steep real fast, right? It's going to look a little something like that. Okay, now we are going to do these transformations. Okay, so we are going to go with each point to the right 2 and down 5. 1, 2, 3, 4, 5. Okay, now this one to the right 2, 1, 2, down 1, 2, 3, 4, 5. This guy to the right 2 and down 1, 2, 3, 4, 5. And I'm not too worried about that guy. It's just giving me a good idea of what it looks like, okay? So now I know my graph is going to look something like this, right? And again, it gets steep real fast, okay? All right, hopefully this made sense, okay? We first figured out what our parent graph was. We graphed that, and then we were able to do those shifts that we needed to do, okay? All right, hopefully this made sense. If you need some more videos like this, some more examples, I'll link a playlist. Also, if this video helped you, if you could hit the like button, that helps me a lot. So thanks, bye.